Okay, so this is going to be it's a short video just explaining the assignment for week 4. So what I'm going to do is I have a data set from heights, and this was collected a long time ago. And so it's very similar to the data that you have here for the NBA players. I'm not using the actual data from the assignment because I don't want to actually complete the assignment for you. So the first thing is that I'm going to go ahead and construct a frequency distribution. I'm going to use 5 classes. Then I'm going to go ahead and draw a histogram. And then we're going to talk about whether or not the data that I have is normally distributed. Then I am going to calculate the mean, median, and standard deviation. I'm going to also find the z-score, so I'm going to show you how to do that. And then I'm going to show you a website that will, you can actually find the probability of any value if the data is in fact normally distributed. So here's the data that I have, and this is the completed Excel sheet. So I do it slightly different than perhaps you were shown in the video that they showed you. So one of the first things I'm going to do is I'm just going to go ahead and delete all this information. And here what I have is actually 1078 heights. So heights for 1078 different males. And so you can see here how I gather, here's my data, here's my minimum, my max, my range, my width, and then I have my classes. So I'm going to go ahead and go through all of this, and then I'm going to show you how to find the probability that a randomly selected father is has a height that's less than 72 inches. So first thing I'm going to do is I'm just going to go ahead and delete all of this real quick to make life a little easier. And that way we can go ahead and start from the beginning. So, like I said, there's 1078 data points. So what I'm going to do is before you construct your frequency distribution, you have to have certain pieces of information. So in this case, I already know that it ends at it goes from A2 to A1079. And so my minimum value is 59. So the shortest male in this data set is 59 inches. And then I need my max, and again, I already know that it goes from A2 to A1079. So the tallest person here has a height of 74.4 inches. Now we need to find the range because that allows us to find the width of the classes. So I'm just going to use Excel to do everything for me. So the range is just the difference between the max and the min value, and I have a range of 16.4 inches. So my range is just going to, my width is going to be my range divided by 5 because I need 5 classes. Now here I get 3.28, but I'm going to go ahead and round up to 4, and I'm going to use a width of 4 for my classes. Oops, sorry. So 59, and since I need 5 classes, I have to do 6 values here. So my min is the starting point for my 5 classes. So that's going to be 59 plus 4, and I'm going to put 4 because it just makes life a little easier. I can highlight the cell, but this is just a little easier. So now I'm just going to go ahead and drag it so I can get my 6 values. So that's 1, 2, 3, 4, 5. I need one more. And so now I have my 6 values. So here, what I'm going to do is I'm just going to copy it, and I'm just going to paste the values because I don't want anything else. And if you recall from when you first did the frequency distribution, what I'm going to do here is this cell is going to be equal to this value minus 1, so that's going to be 62. And then the next one will be 66, and then 70, 74, and then 78. And I don't need this value here, so I'm just going to go ahead and delete that one. So here are my class limits. And now I'm going to create my class boundaries. And the reason you want your class boundaries is because if you use this as your bins, when you create your histogram using the data analysis toolpack, it actually counts all of the data points. And if you don't, you might miss some data points. So this one's going to be 59 minus 0.5 because it has to be continuous, and this is going to be my 62 plus 0.5. And then at this point in time, what I'm going to do is I'm just going to go ahead and drag it. So, oops, I have to do 59 minus 0.5, and then I'll create my, okay. So those are my class boundaries. Now, I have 1,078 data points. There's no way I'm going to count those by hand. So what I do is I create this formula that tells Excel how to count what I need. And I'm not going to explain the formula too much, but if you have, you know, 200, 300 data points, there's no way you want to do that by hand. And so this formula just makes life a little easier. And so this formula, what it does, it actually counts all of these and looks for the data points that are between 58.5 and 62.5. Now I'm going to go ahead and put the $sign because I'm going to go ahead and just drag this, and that way I don't have to type it in multiple times. And at the end, I should get 1,078 data points. And that's why I have this cell here in the bottom with 1,078. So this gave me the frequency for each one of my classes. Now, the next thing is I'm going to go ahead and find my midpoints. And you know that the midpoints is just the sum of the class boundaries, upper and lower, divided by 2. So I'm just going to go ahead and do that. Have Excel do that for me. And so that's the midpoint for the first class, and I'm just going to go ahead and drag everything. So now I have my my frequency distribution or frequency table. That's how they called it in the assignment. So the next thing is I want to construct my histogram. So in order to do that, what I need is the data analysis toolpack. So just make sure that you have that installed. So I click on data analysis toolpack and click on data analysis, and I want histogram, so I'm going to click on OK. My input range is just going to be my raw data. So, and again, I'm not going to highlight the whole thing because I already know it goes to A1079. My bin range is going to be my upper class boundaries, just makes life easier. I want a chart output, and I'm going to put in a new worksheet. And I'm going to go ahead and click OK. And Excel is going to go ahead and put it for me in a new worksheet. So here at this point in time, it doesn't really look like a histogram. So the first thing I do is I delete the more because we don't need that. And I'm just going to make this a little larger. So at this point in time, I want to clean it up a little bit, and I've already done that here in this sheet. But the first thing is I normally just get rid of the legend. We don't really need that. And then we want to reduce the gap. The gap width should be 0. And then at this point in time, we can just change the colors, and it doesn't really matter which colors you use. And so looking at this distribution, let me do this one. This is going to be a little easier than the last one. And I'm going to go ahead and just add the data labels to make life so we can actually see it. So just remember, the bins here, we can change this to the midpoint, and that's not a big deal to do. Change your label, and then of course your title. So this is what it looks like after it's all cleaned up, and this is actually the midpoints. Now the way that you change this from, because if you recall, this is actually your upper class boundaries. You click on it, and you see the box that appears. Then if you click on design, we want to select data. So when you select the data, we can actually edit the horizontal, and when you edit, you click on that, then you go to the cells that is holding the midpoints, highlight those, click OK twice, and then that will put the midpoints in there for you. So if I were to draw a curve, It actually looks like it is a bell curve. Now there are gaps, and that's where the errors come into play because we have to. The assumption is that there will be some errors, right? We won't be 100% accurate. So that's how you put your data. This is how you create your frequency table distribution, and then your histogram. So it does look like a bell curve. So the next thing that I'm going to do is I'm going to go ahead and find the z-scores for each one of these values. But before I do that, I'm going to go ahead and find the mean, the median standard deviation. I don't really need the median, but we do need the average or the mean. So I'm going to highlight that, and oops, sorry. And of course, again, I'm just going to go ahead and take it to 1079, and then equal median. And again, I'm going to take it to 1079. And in the standard deviation, since this is a sample, I'm going to go ahead and click on stdev.s. And again, we just make sure we highlight the data that we want. The data is set up a little differently in the assignment sheet that they give you, but you can actually make it look like this one. So now that I have the mean and standard deviation, I'm going to go ahead and find the z-score for each one. And for this, what I need is I can actually have Excel do it. So I type in equal and standardize. I'm going to double click on that. This is the first data point that I want. So comma, and then I'm going to click on the mean and then the standard deviation. And then I have to put the dollar sign because I'm just going to go ahead and, oops, Excel's acting weird today. Because I'm just going to go ahead and drag these. And I'm going to drag it all the way down to 1078, but you can see how it gives me my z-score for each individual height. So a father with a height of 59 inches has a z-score of negative 3.16. So that means that he is actually over 3 standard deviations below the mean. So if I were to take 67 and subtract the 3.2 times this, I should be really close to the 59. So that's how you get the z-scores. This is how you construct the frequency distribution. So the next thing is, well, what's the probability that I'm going to find someone, randomly choose someone from this data set, and they're going to be less than 72 inches tall? So I'm going to show you that we can actually use a website to do this. I'm going to show you two different ways of doing it. The first thing that I do need is that I do need to find out what the z-score is for someone who's 72 inches, right? So unfortunately, I'm gonna have to drag this all the way down to 72. Okay, so here we go. So someone at 72 inches has a z-score of 1.5708. So here's a website, and you're welcome to go to it to actually do this because it makes life a little easier. So you're welcome to visit this website. It does have a non-Java site, which if you have Java, sometimes computers give you some issues there. So we know that when we do z-scores, what we do is we convert the mean to 0 and standard deviation to 1. So I want, what is the probability that a randomly selected father will be less than 72 inches? Well, they had a z-score, I'm just going to go ahead and copy it, of 1.57081. So I want, what's the probability that someone is less than that or shorter than that? And the probability for this data set is 94.2% or 0.9419. Now, the other way that we could have done this is by simply not even finding the z-score, but using the actual mean for the data set. And you'll see that I'll get the same value. So I can just copy and paste my mean and my standard deviation. And I still want below, but here I'm going to put 72. And if I click on it, you notice that I get exactly the same value. So when we standardize a data set, we're able to compare it across data sets. But this website allows you to do it without actually finding the z-score. Okay? And so I hope this helps. Any issues or questions, just give me a call. Thank you.